This is a key to topic 23, part C, worksheet 1, and in the directions it says find each of the function values using synthetic division, and then it says show all required work to receive points. Now, so keep in mind that when you find these function values, you're actually using the remainder theorem. Now remember, the remainder theorem says this: if a polynomial f of x is divided by this linear factor x minus c. Okay, so remember the coefficient of x is 1. So whenever you're dividing by x minus c, then you can use synthetic division. But it goes on to say this, though, that the remainder, so when you divide this polynomial by x minus c, the remainder is the same as the value f of c. So the value of f of this number here, c. Okay, so that's what that says. So if you want to find f of 3, f of negative 4, g of 6, and so on, all you do is use synthetic division, because basically what you're doing is you're taking this number 3, and it's like you're dividing by x minus 3. All right, so let's kind of talk about this again in terms of number 1. So when you looked at number 1, you're told that f of x was 3x squared minus 5x plus 2, and you want to find f of 3. All right, now according to the remainder theorem, f of 3 is the same as the remainder when 3x squared minus 5x plus 2 is being divided by x minus 3. All right, so when this polynomial is being divided by x minus 3. So you see this 3 here, so that's where you're getting this x minus 3. So that was 5 right here. This would be x minus 5. All right, and so notice I can use synthetic division here. You had this in previous lessons, so I can use synthetic division here because my divisor is linear and the coefficient of x is 1. All right, and so when you do this, you're going to say 3. So you see this f of 3? So 3, and you remember when you actually did this in a previous lesson, you take x minus 3, set it equal to 0, and you get x to be 3. And so this 3 corresponds with this one. All right, and then remember when doing synthetic division, the coefficients here are the coefficients of the dividend, the polynomial that's in the numerator, has got to be in descending order, and any missing terms, remember, you got to put 0. So there are no missing terms here, and it's already in descending order. So I'm going to have 3, negative 5, 2. And so you bring on the 3, and then you multiply. 3 times 3 is 9. You add, you get 4. You multiply, you get 12, and you add, you get 14. So that remainder is going to be f of 3. So f of 3 will be 14. All right. So that's the relationship between what we just did and the remainder theorem. All right. Now, when you go and actually do the work, though, so let's remind you what the work's going to look like. So here's the way you're going to do this in terms of work. So number 1, let's go back to number 1. In number 1, you have f of x is equal to 3x squared minus 5x plus 2, and you want to find f of 14. That's part A. I'm sorry, f of 3, and that's part A. All right, so here's the work. So the work you're going to say is this. So you're going to put 3, and then your coefficients. So 3, negative 5, 2. And then you do just like you did before. You bring on the 3, multiply, you get 9, add, you get 4, multiply, 3 times 4 is 12, put that on the 2, make sure everything is aligned, and you add, you get 14. And this remainder happens to be your answer. So you're going to say f of 3 is equal to 14. Okay? All right, so that was part A. Now part B, they want you to find f of negative 4. So f of negative 4. So you can do the same thing. So negative 4. So remember, that's the same thing as, so finding f of negative 4, according to the remainder theorem, is the same thing as taking f of x and dividing by x plus 4. So x plus 4. So that's where you're getting this negative 4 from. And so my coefficients are going to be the same as these. So 3, negative 5, and 2. And let's see, bring on the 3, multiply, you get negative 12, add, you get negative 17. When you multiply 4 times negative 17, you get 68. And when you add, you get 70. And this remainder is the value of f of negative 4. So f of negative 4 is equal to 70. Now, before we go on, make sure you are following the directions. The directions said use synthetic division. So don't go in there and wherever you see the variable x, you substitute 3. That's not the intent here. You need to follow directions. The direction says find the function value using synthetic division. So the idea here is to make sure you understand that whenever you have a polynomial and you're trying to find a function value, that is the same thing as taking that polynomial and dividing it by the linear factor x minus 3 in this case, x plus 4 in this case. So that's the intent of this lesson. So make sure you understand the relationship between dividing a polynomial and synthetic division, remainder theorem when finding f of 3 or f of negative 4. All right. Okay, so that was number 1. Now let's look at number 2. So number 2, you have g of x is equal to 2x cubed minus x squared plus 2. And you want to find g of 6. I want to find g of 6. So remember, again, I can use synthetic division here because according to the remainder theorem, finding g of 6 is the same thing as the remainder when you divide this by x minus 6. So using synthetic division, 6 goes here. So this number goes right here. And then your coefficients. Now notice I am missing a term, missing the x term. So you need a 0. And it's already in descending order. So I have 2, negative 1, 0, and 2. All right. And so bring on the 2. 6 times 2 is 12. Add 1 and a negative 1 and 12 is 11. Multiply 6 times 11, 66. Add, you get 66. 2 times 66 is going to be, 6 times 66. This right here, 6 times 66 is going to be 396. And when you add, you get 398. And so there's your remainder. And that remainder, according to remainder theorem, is the value of g of 6. So the answer, g of 6 is equal to 398. All right, number 3, you have h of x is equal to negative 3x to the 4th plus 2x cubed minus 5x minus 1. And the a part, you want to find h of 5. So according to the remainder theorem, the value of h of 5 is the same as taking this polynomial and dividing it by h minus 5. That's what that says. So the value, according to remainder theorem, all right, I'm just going to write it out again. Make sure you understand, according to the remainder theorem, all right, according to the remainder theorem, the h of 5 is the same as the remainder when this polynomial, let me write it like this, when negative 3x to the 4th plus 2x cubed minus 5x minus 1 is divided by, and remember you want to find h of 5, right? So it's the same as being divided by x minus 5. Okay, if it was h of negative 5, this would be x plus 5. Okay, so that's the idea. Okay, so but here's the work you're going to do. So the work you're going to say is this. That's what you have to show. So you can put 5 and then your coefficients. I am missing the x squared term, so I'm going to need a 0 at some point. So I have negative 3, 2, 0, negative 5, negative 1. All right, so let's bring on the negative 3. 5 times negative 3 is a negative 15. Add, you get negative 13. Multiply 5 times negative 13 is going to be negative 65. Use a calculator if you need to. 0 and negative 65 is a negative 65. 5 times a negative 65 is a negative 325. So that goes here. Add these up, negative 5 and negative 325 is a negative 330. Then you say 5 times negative 330 is a negative 1,650. Add these, a negative 1 and a negative 1,650 is a negative 1,651. So there's your remainder. And so your answer, you're going to say h of 5 is equal to negative 1,651. Okay, B part, you want to find h of negative 6. So same thing, you do the same process. Here's your work. You're going to say negative 6. And then your coefficient will be the same as these. So I'm just going to rewrite this over. Negative 3, 2, 0, negative 5, negative 1. Bring on the negative 3. Multiply 6 times negative 6 times a negative 3 is 18. Add, you get 20. Multiply negative 6 times 20 is a negative 120. Add, you get negative 120. A negative 6 times a negative 120 is a positive 720. A negative 5 and a positive 720 is 715. Negative 6 times 715 is a negative 4,290. And when you add these up, negative 1 and negative 4,290, you get negative 4,291. There's your remainder, and that is your answer for the value of h of negative 6. So h of negative 6 is equal to negative 4,291. All right, now remember, that's your work, so don't go. So now you would get the same answer if you substituted negative 6 wherever you see the variable x, but that's not the intent here. Make sure you follow directions. You must use what I just showed you. You must follow the directions. All right, and then finally number 4. So let's do number 4. So number 4, you have, let's see, so you have f of x is equal to x to the 5th minus 4x to the 4th plus 2x cubed plus x squared minus 5x plus 1. And you want to find f of 2. All right, so I can use synthetic division here in the remainder theorem because I have a polynomial, and finding f of 2 when you have a polynomial is the same as finding the remainder when this is divided by x minus 2. So I can use synthetic division. So 2, and then your coefficients. There are no missing terms. You can see there are no missing terms. X to the 5th, x to the 4th, x cubed, x squared, x, and constant. If there were, though, you remember you put a 0, and just make sure it's in descending order. So 1, negative 4, 2, 1, negative 5, and 1. Okay, bring on the 1, multiply, you get 2, add, you get negative 2, multiply, you get negative 4, add, you get negative 2, multiply, you get negative 4, 2 times negative 2 is negative 4, 1 and negative 4 is negative 3. Notice they're all aligned, okay? Then multiply 2 times negative 3 is negative 6, add, negative 6 and negative 5 is negative 11, multiply 2 times negative 11 is negative 22, and you add, and you 1 and negative 22 is negative 21. That's your remainder, and that is the value of f of 2. So f of 2 is negative 21. So that negative 21 is the same thing you would get if you took wherever you saw the variable x, you substituted 2. Okay, but the direction said use synthetic division and the remainder theorem. All right, and so that's it. So that is the key to this worksheet.